Have you ever played tic-tac-toe when you were a kid? Getting tired of this simple game? Then I would like to introduce a big version of it, tic-tac-toe plus Gobang. Gobang is a Chinese traditional abstract strategy board game, and is played with black and white go pieces called stones. Typically, black plays first and continue to play first for each new game until white wins. Players alternate in placing go pieces on an empty intersections. A go board normally has 15 times 15 intersections, and the pieces cannot be removed once placed. Gobang has several different names across country, such as Gomoko in Japan and 5-winner row in England. The winner is the first person to get an unbroken row of 5 pieces, horizontally, vertically, and or diagonally.
Hiya!
Hi!
What are you doing now? Oh, Gobang! That's cool. How is it going now?
It's a really tough time. She always wins.
Oh, let me see. Oh, you will win this time, Ning.
What? You sure? I'm struggling.
Yeah, I'm pretty sure you will win as long as you...
Okay, let's see what will happen. What? How did that happen? I tried my best, but I couldn't stop you.
Oh, let me tell you why.
Let's use thread to help us understand this game better. There are 4 types of thread in Gobang. 4, open 4, 3, broken 3. 4, 3, broken 3 are called single thread, while the open 4 is called double thread. If a player constructs a single thread, she's threatened to win on her next move, but there's still some chances that her opponent could stop this. However, if a double thread is constructed, it's too late for the divider to take any actions, because she could only counter one thread one time. So in order to win the game, we need to try to create double thread. It can be an open 4, 2 4s, 2 3s, a 3 and 4. We only consider it when there's an open 4 now. In other words, when it is our turn, if we already have an unbroken row of 3 stones that don't have any stones of different color placed next to them, then we can construct an open 4 and guarantee to win. So what we need to do is try to get this row. Let's look at our game. It seems like quite a peculiar situation for us. Our opponent is very clever. She set on 2 unbroken rows of 2 stones in a non-obvious way. If we hadn't noticed it, she would have only needed 1 stop to win. Fortunately, we spot it and we can turn it around. We place our stone between these 2 rows. Our opponent will definitely play her stone here, because if she doesn't, we can place our stone in the same place, and then there will be an open unbroken row of 4 stones, and she wouldn't be able to stop us. Then we notice that although we can't find a point where we can put our stone and create 2 open unbroken rows of 3 stones, if we just place our stone here, it will create 2 potential open unbroken rows of more than 4 stones. Our opponents will try to prevent this. She will definitely place her stone here. Otherwise, we can place our stone here and win the game. However, even if she does this, she still can't stop us, because we create a kind of special open row of 3 stones at the same time. We can place our stone here, and our opponents will try to prevent this, but she can't, because we win.
We can also create a coordinated system to solve this problem. Position of the stones when the 5 stones A1, B1, A2, B2, A3, B3, A4, B4, A5, B5 satisfy certain mathematical positions. We can call it a win. The mathematical part is with A1 to A5 and B1 to B5 being an arithmetic progression. The common difference between A1, A2, A3, A4, A5 denoted by DA and B1, B2, B3, B4, B5 denoted by DB. There are only 4 possibilities. The first one is DA equals to 0, DB equals to 1. The second one is DA equals to 1, DB equals to 0. And the third one is DA and DB both equals to 1. And the last one is DA equals to 1, DB equals to minus 1. In other words, DA and DB's absolute value both equals to 1.